Alright, hello. Welcome back to the channel where we are building a video game from scratch using Love2d and Lua. Yesterday we got some things working for our Game Boy UI, like we have the ability to kind of resize, like toggle on and off our Game Boy UI, so that if you're playing on desktop, you can play with the keys, and then if you're playing on mobile, you'd use the touch device, on the bottom there for the D-pad and the buttons. So now that our game is going to be moving our character with not just arrow keys, right now it's just arrow keys, but we need to move the character based on touch detection for the D-pad as well as the WASD. We're going to switch off the arrow keys so that our keyboard input is going to be WASD for D-pad, and then I'm thinking O and P for the B and A buttons, and then maybe enter for start, shift for select, or something like that. I might, that's not that big of a deal, but the hard thing is there's a lot going on with our inputs, because if you look at when we walk, our direction is not based on which direction we're moving, because look, we have two different directions. So if we walk down then right, we walk down and to the right while facing right. But if we walk right then down, we walk down and to the right facing down. So the way we did this was we kind of kept track of which inputs were being held in which order, so that you kind of responsively walk in whatever direction you last held. So it just felt nicer to me to do it like this. So I would like if we can keep this with our new input system handling, but right now we're doing this based on key touch detection and not any touch detection. So, and you know what? We have a magic number in here that we need to switch, because here, let's do... Let's put in every 2 on here needs to be the scale reset. So that we don't shrink the screen. Can we start that big, and then when we... Oh, we're screwing it up. We're screwing it up. Yeah, it's that this number, this 2 right here, doesn't need to be reset. Just this one and this one. There's a better way to do this, I'm sure, but for now, just so that... Actually, yeah, substitute every 2 with scale reset. This is because we hard-coded in a 2 on the scale reset for the G pushing, and we're still screwing it up. Okay. This is not what I wanted to worry about. Oh, we only want to do it... So this is the non-Game Boy UI, and this is the Game Boy UI. So when we go to do this, that 2 is fine. Yeah, I think it's just... Man, I should know this better because this is my own code, but... why is it that scale factor times 3, that's fine, but then we switch it back and it gets smaller to bigger? I guess this... It's weird because we initially start the game with a bigger scale factor for the Game Boy UI as I just switch it. See, like that's the one we want. It's tricky because by the time we deploy it to our website again, we want it to be back to this. So I don't want to mess with it too much. But why is it? Oh, I think I know what it is. I think it's right here. This needs to be the original scale factor. So let's try that. Okay, so that's it. Let's assign this to scale factor reset. That is a variable that we don't change, so that it's gonna be, I don't want to, we need a second variable there. Like, you know, it looks like we can just get away with, we're saying the same number, but this number is changing depending on when we reset it. So I think we need to do something kind of like that. Yeah, we reassign the scale factor. Okay. Yeah. Okay, so how are we going to go about rehauling the input list? If we look at, we do have a input list right here that it holds whatever button is currently being held down. And I think there's a couple of different things that makes this tricky, right? Like, see how we can hold right then up and it knows right up, but if we hold up and to the right, it says upright, and that's how we're determining which direction of a sprite to render for our character. So like, it's the last input is the one we're doing. If we translate this to a D-pad, it's going to be a little different because you're not really going to be holding up and to the right two buttons on the D-pad. It's going to be, you're going to be using your thumb diagonally at the upright. So it's almost like, yeah, I don't know how we would do that, because if you just touch top right, it has to pick a direction on your D-pad. So maybe we can do it where, like, if you just touch up and to the left, we know you're facing up. You know, that's a whole another can of worms. And then we have some stuff like, you know, if there's multiple inputs, you don't move the character. So there's like a lot going on. And then if there's multiple inputs but 3, you would switch to whatever you're currently facing. So there's a lot of weird stuff. And then 4 inputs means you don't move. Gosh. So I think the way I imagine tackling this, see, and this looks wrong. Looks like we scoot up every time we do this. It just doesn't look right. Okay, so in my mind, the way to kind of handle this is to take it one step at a time. And first of all, just capture all the inputs that are being held and make sure that we don't ever include duplicates, right? So it's like, if we'd have to populate an input list of whatever directions we held. Now, for the D-pad, I guess the input list would technically include the diagonals. So part of me thinks that the way to do this is to handle it separately, in the sense that handle the keyboard input in one way with its own table, and handle touch input one way with its own table, just so they don't counteract each other. It's not so performant in the sense that we'd be listening for touch inputs at all times on the keyboard version, but I don't think it matters that much. So I think we'll go about it one step at a time. Now the goal is, let's render. Let's get a table of our inputs in the order that we input them, and make sure we can't have duplicates, or because like another tricky thing is like we're kind of holding off inputs while we're transitioning screens because we don't want the character to be updating, but I actually think we can get away with not caring about that. Because look at our let's look at our input list table, and as I'm transitioning, I'm holding down, but it doesn't update because we're transitioning. So we'll just test it, I guess. So like the first step is get all our inputs in a table, make sure there's no duplicates in case something went wrong, because we have to clear our input list upon a release. And if we're only we have to be checking at all times for a key release. So let's make sure we can populate which key's being held and which order they were being held in, and release it. And then we will have an input list, right? And then we need to convert that input list to an output direction. So if there are only two directions in our output table, and they are left and right, those are contradictory inputs, so we just won't do anything with the output of the character at that point, because it's hard to hit them at the same exact time, so I think that's why it's kind of like flipping out like this. Like it shouldn't look that wobbly when we spam left and right. So hopefully our new implementation can fix this. And then same with up and down. It just looks a little wobbly, right? Like our bottom, yeah, I don't know. We shouldn't be modulating on the Y at all for the top of our head. Our feet come up with this sprite sheet, but our Y shouldn't be moving at all for right here. So I don't know why. Yeah, see, look, our Y isn't moving, but for whatever reason, it looks like the top of our head's moving up and down. I don't know what that has to do. I don't know why that would be happening. So hopefully we can fix that. And then we'd have to go about doing the touch detection totally separate. So with the keyboard, we're going to have to say like, okay, well, let's say our input list is up and to the right. Which order were they in? Was it up then right or right then up? Because we need to know which direction to make our guy walking. Either like that or like that. Walking facing up or walking facing right, depending on the last input. I think that plays nicer. Now in Link's Awakening, they do it differently. They do like a strafe. So like you only face the same way you were originally facing, because if you have a sword and shield in front of you, it makes sense to kind of aim that way. But our spellcasting's a little bit different than that. So I think it's okay to change it. I mean, ours, I think it makes sense for us to change it, but I guess we'll see once we have more than one spell. Right now we only have one spell that kind of just goes around us. So let's try to handle. We've got a couple of things to do. We've got to basically undo all the player input detection based on key presses, and instead change the direction based on the output list. That's what I'm calling. We have an input list, and then we pare it down to only like the latest two objects. Because if we hold 4 directions all at once, we shouldn't do anything. So if our input list is 4 directions, we're just not going to do anything to our player. So we'll have to kind of undo all the logic we have so far so that we can redo it with a certain variable. Like, I don't know, once we change the players to move based on touch, if we get a top right touch, what does that mean? Well, we know we've got to do our root 2 negation to give us the proper velocity in a diagonal direction. But I'm not sure what that means in the sense of the game code, how to... Because right now we're saying if the key of right is pressed, move us to the right. But we also need to move to the right if the right D-pad is touched. So ideally, I'd like us to be able to say something like, we can convert all of our keyboard inputs into an output list and convert all of our touch inputs into an output list, and then only modify the direction of our player based on the output list, if that makes any sense. Because then you know, we're only modifying the player under one condition, and we're not checking the touch conditions in order to render the keyboard movement. We're checking them anyway, but we're only moving them based on the output list, if that makes any sense. So I think the first step here is to just remove all of our old logic that moves our characters, and we'll just start with the input list first, and then start with chopping down the input list into an output direction based on the list. So let's see, any time was pressed is in our program, but it's left and right. So let's just see what left being pressed is. Okay. So we have a global input list in our scene. Oh my goodness, what the... This was an attempt to fix some errors. I think this came about because we were stuck in an animation when no keyboards buttons were being held. That means our love key pressed released. Our love key released function wasn't being called properly. So I think one thing I want to do is just like, we're going to call this, we're going to give us like some global comments here called like input rehaul, so that we have a location of what our old code used to be, but we can reference it still, right? So we've got input rehaul right here. Because if I just start it from scratch, I'll probably forget about some of the projects or some of the problems we had. Input list here. So yeah, we need to get rid of it here. Possible directions, okay. I don't know where we're using that. But here, we'll call this another input rehaul. This is going to be so messy. This is probably the biggest refactor I'll have done. So this is in our scene class. And I think it would make sense to do this in the play state, or our main, honestly. Like, I mean, we just need... we don't want the input relying on the current scene. It should exist outside of the scene or the map, right? Like, so it should be kind of global in a sense. The input is like one of the most important parts of any game. So we have in our player class, we have input list. So this will be called input rehaul. And I'm titling them all with the same thing so that we can go in the future, and once if we succeed, that we can come in and go delete all of our old input rehaul that we don't need to reference anymore. Wow, yeah. See, look, so here's all the release functions. See this? It's weird that this is in the player class to me. I feel like it should all be in one spot. Holy crap. Yeah, there's a ton of stuff going on. So we're changing the animation based on the last input, and then we're dispatching transition events based on the player's location, which this is how we walk from screen to screen. And I did it like this. This is weird. Like, I don't think we should necessarily do this, because, like, let's say, for example, an enemy knocks you off screen. Like, should that be possible? Probably not. I had this in here so that you couldn't walk through a scene without holding the direction of the scene transition you're doing, which means that if you get knocked off screen, you'll just not know where you are. So maybe we should just implement a change where you can't get knocked off screen like that. So that was a lot. Our player class had a lot of our input logic. So let's continue to look. Oh, jeez, man. Okay, that's different stuff. We're looking for was pressed down. So this isn't stuff. Okay, here. That's different. Holy crap, okay. This is in the player walk state. We have a bunch of this stuff. Oh my gosh. Yeah, this is something we should have figured out first things first, right? I didn't know we were gonna put on the phone though, so that's okay. You know, I thought worst case scenario, we just come in and change all the ups for W's for WASD, but this is all the weird input limiting stuff depending on how many directions are being held. And it looks like if the player's not falling, we go and do all this stuff. This is really strange. If the player is falling, be falling, okay. Okay, so where's the end for this? Right there? There's the end. So this is another input rehaul. This might be the last of it. See, and I really don't like that it's split upon 5 different files. You know, we had some in the scene, we had some in the player class, we have some in the walking state. Ideally, we're just worried about populating it in one spot, and then we can associate all the results in the correct spots. Okay. I'm leaving all the code so that I can come in and be like, okay, so this is where we were doing the change to animation based on the last direction, so that I have a reference to like what the heck I was doing. Where are we using this possible directions? Okay. We use possible directions to give our entities a random possible direction. Okay. Okay, so if we run the game, we shouldn't crash. And holding any directions doesn't do anything to our input list at all. So it looks like we probably got rid of it all for our player. Okay. So the first things first. Let's see where our input list. Do we even have input list defined anywhere? Anymore? I don't think we do. Holy crap. We define it to be empty from the constants. Okay. What are we doing here? If we collide with a pit, if we're not holding any directions, then we'll trigger the tween. I think we want to change that. Okay. So I think we pulled out all of our old logic, so let's try to just get our input list populating with the right order and depopulating with a key release. So where should our input list live? Should it live in the play state? Or should it live in the main? I kind of feel like we should make our own input handling class and just put all the handling in there, put that in main, and just call it a day, right? That's kind of what I'm feeling. Because I want it kind of separate. I want it to just be like abstracted away in the... We know we're getting the right inputs because we tested it and it's being imported in a main and it's just going to work. You know? So, let's go into our source, and this is where we put all our classes, and we'll make a new input handling.lua. Now we'll give us a class called input handling. There'll only be one instantiation of this, or maybe we'll make touch input handling so we can toggle on and off which ones we need for each version. So maybe we'll do that. But we have to say input handling gets class curly brace like that, I think. And then we need 3 functions. We'll need an init. We'll need a update. And a render. Okay, I think we did this right. Let's double check a random class of ours. Yeah, entity gets class curly brace. Gets class curly brace. Okay, so we do need to go to our dependencies and make sure we require this so that we know we have it. So our app knows we have it. Okay, source input handling. Okay, we require it, so let's go to our main. We'll initialize in our love.load a input handling for keyboard. So we'll come in here. Ugh, I don't like a lot of this stuff. Let's call it keyboard input gets input handling function like that. Then we need to update our keyboard input over time. Keyboard input. So we'll go to our update and we'll make sure our keyboard input gets updated every frame, and then we need to render whatever it is. We don't need, you know, at the end of the day, we don't need to render anything from the keyboard input, but for testing, we would like to see it. So it's not that we update, it's that we render. Okay, so we shouldn't crash. We should have access to our input handling class that is now part of our main function. So now, if we go to our source, I'm going to harpoon our input handling so that we have access to it. And I'm going to say that we can just jump to it from here now. Our init, I guess it would make sense to maybe put now our input list. Input list is a class, empty table, not a class, empty table here. I don't think we would need anything in the init actually, so let's just do a test here where we say if love.keyboard was pressed, let's just do is down for a test. We're gonna say W. If W is pressed, then input list is gonna get, we're just gonna say input list 1 is gonna get the value up as a string, and then else flush our input list, just so, you know, I'm just trying to get something on screen here for us to see. Else input list is going to be flushed to an empty table again. And then all we have to do is a love.graphics.print, and we're going to print up input list. I'm just going to say input, and then print out the whole input list. So to string input list. Now, input list is a table, and it doesn't know how to print that up. So we might have to do the old inspect, and inspect means we would need reference to the inspect. I want to say it's inspect, like this. Then we can print a table as a value, and then we need to set our color so we can see it. We'll just set it to white. Okay, inspect is not found. Let's see in our dependencies where inspect is being imported. It is, where is it? libinspect. Libinspect. Local inspect gets require libinspect. Okay, let's try it. Okay, we've got an input table, and if we hold up, we have up in the input list. Sweet. I wanna, there's another font I have that's a little different. Let me see where that is. Pixel, maybe it's called? Pixel or small font? Let's see. How do you do font? Set font. That's the one I'm at. New font. Set font. Classic font. Yeah, that's very tiny. Okay, well that's okay. Let's do excuse me. I'm gonna put we have like a debugging color, debug background. So we're gonna set our color to that. Then we're just gonna fill a little rectangle so that we can see where we're doing this. Okay. Yeah, maybe debug background too. Okay. You know, just so we can read a bit what we can see a little bit better. So I'm just gonna say that this is a width of a virtual, or a window width. Actually, a virtual width. I think that might be wrong. And then height, let's just say 10. Let's see. Okay. Okay, so this is our test for this. I want, for this development process, you know, I don't want to keep loading in the Game Boy version, so let's set our default stuff to be our default load to be the Game Boy, the non-Game Boy versions, because it's just too tiny, you know, that it doesn't help us that our D-pad's on here, and I don't have to hit G every time. So we can afford to make this bigger. So let's say we've got, I think it's in our play state we're doing this. Yeah, let's set, you know, if love is pressed, if we're set to be the original scale factor, we're going to set it to be this scale factor. So I think when we go ahead, I think that just means we need to change. All of this stuff will be our default value in our constants instead of where they currently are, which is window width and stuff. Window width, all this stuff. All this stuff. Let's say after that, oops. This is what we want. So we'll go back to our constants. Okay. Sweet. So let's try to just scale up just a bit. Okay. And then we have a lock position right here. This is our this will be the Game Boy toggle position, but for our development, we want a little bit lower, right? So I think 400's fine, but then we want it lower, maybe like 100. Sweet. that looks good. Okay. So we've got an input list, and now we have that our input list is up when W is pressed. So there's a whole bunch more that needs to go on. You know, we need left to be put in there if A is held, S and D also, and then I guess, you know, it's tough because I want to say only input a direction if it doesn't already exist in the table. I don't know if that's overkill. It shouldn't exist in the table because if we're checking for continuous input and every time the key is released should trigger the callback, which would then remove that key from the table. But we had some issues in the past of trying to do that, so let's just go at it the simple way, and if we run into problems, we'll have to get fancy, I guess. So let's go into our input handling. Now, instead of inserting based on an index, we'd want to do something different. We'd want to do a table.insert into our input list the value of up as a string, and then we'd have to do something different, right? So it's like for the removal, let's come up with a standard order so that I can keep my stuff sane, I guess. Let's do left, up, right, down. Does that make sense? Left, up, right, down. Like clockwise, starting left. So we're going to say A is left. W is up. Okay, so here I instantly see a problem, right? D is to the right, S is down, so S is down. So what will happen here is our table will get filled up quick because we're never deleting anything, but we're also inserting keys willy-nilly. We only want to insert this stuff if it doesn't already exist in the input list. Let me think of like do we want to do this upon, if we do it upon the callback of was pressed? I think we might want to do that because we, you know, it's not, if we hold it for continuous input, then it would go through and say, okay, well, I know up is held down, so I'm going to go insert it into the input list table. Oh, by the way, up is already in the input list table, so I'm not going to insert it. But it should just be like, well, no key was pressed, so why would I go to see that there's something in there? You know, so I think it should be on was pressed. And then that means, well, we have our D is right. So let's try to do this where we say not is down, but was pressed. Okay. Let's see. Okay. And then I also want to print up how many values are in this table. So see, we can add more inputs as we do that. So we need to remove them as the key is up. So this is where we insert it into the list. Then if the keyboard was released, so let's see how this works. If the keyboard was released, we want to remove, let's see, table.remove list and position. So it would take in input list, but then a position, like the index of the value. So we need to cycle through for index value. Let's do it key value in pairs. Can we do I pairs here? It's an array, right? It's just an array of strings. So for key value in pairs, input list, cycle through our input list, and if the key, actually if the value is equal to the string left, then we want to table remove the index from that input list. So we should be removing A upon a release, but let's see. Left is in there. Oh, see, look, it's when I'm holding it, it inserts it on top of the other left, and then when I release, it releases one of the keys, one of the indexes that was left. So we do want to only insert these if it doesn't already exist in the table. So it's got to be a better way of doing this, though. Like, how would we say? Yeah, I guess it makes sense to do something similar. Gosh, for key in I pairs, I'm gonna cycle through all the input lists, and for key value in I pairs input list. Oh god, see, like, this is already an issue. Because we have to insert only if none of the inputs are left, not if any of them are. So, like, let's just say that we have a left count initialized to 0, and for every input that's value is equal to the string left, because that's what we're trying to remove, we're going to say if the value's equal to left, then we want to say increment our left count. This is weird, because then we have to say we would only want to insert it if there's and what we can do here is, in here we can say if left count is greater than 1, then go ahead and break, because we don't need to count We just need to know we only insert the left if left if the left count is equal to 0 after we've cycled through all the input list and there's no left count, then we go ahead and insert left into the table. I guess there could be... Hey, thanks, Matt Gatonics. What's up? Always nice to have you stop in. Okay. That is only inserting one at a time, but it is not taking out every left instance. I'm trying to think of a better way to do this. Let's try something else, and let's say we're cycling through our input list, and if the value in any of those lists are equal to the string left, meaning left is in our input list, then we want to break out of this loop. But then, yeah, we would only insert left. This isn't quite right. We've solved this before, but it's bad. So I don't want to go back and look at what we did because I think we did bad. So, what is the way to do this? We only want to insert this left if there's no lefts in it already. So we can say, you know, we have to check all of them. So if by the time we're done cycling through all of them, there's no lefts. Yeah, that was my initial thought, but it wasn't quite working. Okay, we're not inserting it if it exists, so that looks like it's right. It's just that when we go to the release... Oh, why are we inserting it? Yeah, okay. If we go to the release, we cycle through. If the value has left in there, we remove it. And that goes for all the lefts, even if there are more than one. We could just break, and we probably should, but... Okay, left is in there. Okay, cool. So now we can't add left if it's already in there, so that's good. So let's do the same thing where I guess if we remove it, then we can break through the loop because there should only be one left in the input list anyway, so Okay, left is being removed correctly. So let's mimic this. But what we can do, we can turn this into a function that takes in the direction, right? So if this is what we want to functionalize and say insert direction, we can say insert and we can give ourselves a function up here. And it's going to be called, it's going to be this insert direction. And it's going to take in a direction parameter. And it's going to make, yeah, we're going to put maybe just direction count here. We're going to say, oops, any left count is actually direction count. And then the value we're checking is the actual direction that we pass it. And the value we remove is the actual direction that we pass it. So now we have a little function that goes ahead and only inserts a direction if it doesn't already exist in the input list. So A should still work. Yeah, so we're still removing it. If, oh, wait a second. What the fuck? That's jacked up. I hold left, then I hold down, then I let go of left, and we remove down. What the fuck? What? And you know what? I'll put on my keylogger again. So that y'all can see what keys I'm pressing, but we also need to we need to change this to WASD now. Arrow keylogger. See, where are we doing this? Okay, so let's change. Left is A. Right is D. Up is W. Right is what? Down is S. Okay. So our keylogger down at the bottom now. Now you can see what keys I'm pressing. So look how jacked up this is. We hold L, it's left. We hold down, it's left down. Now we let go of left, but hold down, it still thinks input is left. That is just jacked. So if A is released, we're cycling through all the I pairs, and if the value is equal to, oh yeah, not left, oh yeah, the value, yeah, is equal to list left, we're gonna, oh, this is not index, this is key. Okay. Yeah, and then we want, I think we do want this, but we also want to kind of functionalize this, right? To be a, remove direction left as a function, right? So left is the parameter. So let's come up here and we'll have a remove direction function. That takes in a direction parameter, and we'll do the same stuff, and it's going to be if the value is equal to the direction, then remove that key that is equal to the direction and break. Because we should only, you know, we're only inserting here, we only insert if there's no duplicates of the direction, so we shouldn't have an input list with multiple values. So if we remove direction left, cool. Let's use our function here, which is why we did it. So like now it looks, ideally this should look really clean. I mean, it should look simple now that we're doing the oh, come on. Here we go. Okay. So W we want to insert up. D we want to insert right. S we want to insert down. And then we want this for the other directions as well. And if we go left and then up, and then right, and then S is down. Okay, so look, now our update for input handling is simple. Like if A was pressed, we insert left, you know, blah blah blah. If A is released, we remove left. But under the hood, it's also saying like only insert a direction if it doesn't already exist, and remove the input and break from the list, so you don't have to cycle through them all unnecessarily. So let's see if that's working. So left, up, right, down. Now it does have the correct order, so that's good. This is good so far, and it's a lot cleaner than our old solution, so I need some water. I'll be right back. I'll get some water. Be right back. Okay, I think it would be nice if we can get the touch detection handling in the same way on screen. So let's take a look at how the touch detection is handling the key button presses, and instead of actually, yeah, like we already have a list of the touch detection objects that are being pressed. So all we'd have to do is something similar where we insert into the input list table based on the values of the buttons that are pressed in the D-pad. So it looks like we do this in our main.lua, which we want to move out of our main.lua. So I think this is the perfect opportunity to refactor this touch detection outside of our main.lua, because we don't want it bogging down our main.lua, which it is. So let's make a new, yeah, we'll get rid of all this junk. Okay, I think that's the move. So we'll come in here and we'll go okay. We'll go into our source. We'll make a new class called touch handling. So we'll make touch handling.lua, and we'll say that touch handling gets class empty brackets. Then we need our init function. Okay. We need our update function. And a render. Okay, so here's where we can migrate all of our junk from our main. So I'll go back. We'll have to put touch detection or touch handling. I'm going to put touch handling in my harpoon, so we have it here. Okay. Touch detection is the class of touch detection objects, but touch handling is actually populating our input list and everything. So let's do this. Okay. Let me think this through too, because like once we hit, if we hit a diagonal to the right, what goes in the input list? Up and right? I don't know. Yeah, I really don't know. Okay. Let's go through our main. We need anything that is related to our touch pressed. So here is in our update, right? No, this is still in our love.load. Okay. So in our love.load, we're just defining touches and then modifying our callback functions here. So this will all go into our love.load for our touch handling. Why do I... How? I can't just indent this? Gotta be a better way than this. Okay. So there's our touches. We just modify our callback function to do different things. And then anything that has to do with touch here, we have a... we don't need this, dude. We're not doing anything with this, right? Yeah, we don't need this. And we're not doing anything with mouse down anymore either. Yeah. Okay. So in our update, we need this stuff. Then in our render, we need this stuff. Okay. So a couple other things. We need to go into our dependencies and make sure we require our touch handling. And then we need to instantiate it a lot like we do our keyboard input. So we'll say touch input. It's going to get our touch handling class. And then anytime we have our keyboard input, we need our touch input to be updated. And then rendered as well. Okay, so we got our keyboard input, got our touch input. We need to now do a similar thing with our touch input that we were doing with our keyboard input. Come on, camera. Find your focus, buddy. Maybe I just need glasses. I look blurry. I look blurry. I'm blurry, right? Whatever, dude. Whatever. Okay. So let's if we go into our touch handling and we go into the update, basically all of our buttons that are pressed, you know, we need to know which buttons are our up, down, left, right. So I can make a little list here of like One is up left, so 2 is up. Left is 4. Right is 5. This is jacked up, but don't really want to move it around. Down is 7. Okay, so those are our 4 directions. We still have to decide what to input for diagonal inputs. It depends how we modify. I believe our diagonal input is added based on the number of inputs in the input list. So I kind of feel like if we detect our... I'm just going to make the call that if we do diagonal inputs, we're just going to input 2 directions into our input list table. Yeah, I mean, I don't know. So up left is 1. Okay, so upright is 3. Down left is 6. And down right is 8. Okay. So now we know which index of our D-pad to ask which button is pressed in order to know which values to insert into our input list for touch detection. So I think it makes sense to modify our input list, because the thing is, if you're on a touch device, you can't do a keyboard input, and if you're on a keyboard device, you can't have a touch input, right? Well, I guess there are some certain like tablets that can do touch, but you can't input more than one direction, so I think it's okay that we do it like this. I'm curious if we crash or not. Yeah, global button timer, a nil value. That's because, where do we use this button timer? Okay. So we'll just make button timer and button test out locally. Okay. So in order to test, well, first of all, we need to do the same thing for our touch handling that we're doing for our input handling, which is to insert the directions based on certain values here. So yeah, it kind of makes sense to me to have, well, I don't know. I don't want to just copy these functions into touch handling and use them here. But that's exactly what I'm doing. It's disgusting and I feel bad about it. I do. The alternative is to put our touch handling inside our input handling, which technically makes sense. But then touch handling is jacked up with our touch and input handling. I think it's okay to keep it split like this. So if we look at our input handling, it should call it keyboard handling, not input handling. Yeah, it should be called key handling because touch is also input handling. So let's see here. We check for the thing and we insert it, and we check for a release and we release it. That's all we're doing. So in our touch handling, in our update, we're going to do the old, go ahead and do all of your flushing buttons to be pressed and only become pressed if we're colliding with a touch. And then I don't know what the hell is this button test? We'll get rid of this button test. We don't need this. Okay. So it's not that. Yeah, let's get rid of this button. Test and timer. We don't need that. But we do need. We want to insert direction if the key is pressed. So we need to cycle through. Okay. So we need to cycle through our D-pad. So we'll do for key value in our pairs of D-pad. We'd want to do and see if, and we can do, I normally call this button, or I call it index and button. And we can see if button dot pressed, then go ahead and insert a direction that corresponds to the button that is pressed, but we don't have that. We could add to our buttons a string of. Yeah, we could add a string field. So we can say like, we would say insert direction, and the direction is the button itself dot value, or like dot value or dot direction. But we would need to make sure that diagonals have a dot direction to be put in there. But our insert direction function does not take multiple directions. It's tough. For right now, we can just try to put in simple values. It's going to be tough enough to test with the touch device going on for us, but we can try this. See, this is tough because we don't want to insert upon the button being pressed, because then we have the same issue of inserting into a table over and over and over if the button's pressed. We only want to do this in the callback. Yeah, it's gonna get messy. I mean, I don't want to clog down our callback function for a was pressed to check for collision of every freaking button, because then, yeah, I just don't think that's a great idea. I might have to really think about this, because We'd have to remove the direction once the touch is no longer colliding with it, right? So we could just flush the input list. Well, yeah, we can't do that. We can't do that. It's quite tricky, I think. Oh, yeah. Okay, so the issue is we're trying to populate our input list, which is just a table of strings of whatever direction's being held based on touch. So like we're trying to say if the right D-pad is being touched, go ahead and insert the string left into our input list table if it doesn't already exist. And also, if the touch moves outside of that collision and is no longer colliding, we'd need to remove the left from the input list as well. But that's tough because if we say if none of the touches are colliding with the left D-pad, go ahead and remove left from the table if it exists, then we still have keyboard to think about because left could be held on keyboard, but it's not detecting a touch collision, therefore it removes it from the table. So I think we might need a touch list as well that's kind of mimicking our input list. Oh man, it's tough. It's tough. But then how do we go about only populating the input list with what's currently being collided? We would have to come up with a second table of touch input lists, because that way we can flush our touch input list at the beginning of every frame, and only for the touch detection objects that are colliding with a touch, insert that values string into the touch input table if it doesn't already exist. So let's modify this. So we have a touch list. Okay. Okay. Then let's go to our input handling and we'll make sure that we render our touch list as well. Okay. Okay, we are inputting. This is weird. This is really strange. I think functions are functions global. Gosh, I think functions are global in Love. That's the only explanation for this. Let's see. If we call this touch, and this fixes our problem here. Let's see. Insert direction. Insert touch. And then remove direction. Remove touch. Let's see. This is really strange to me. Why is the touch being detected here? Oh. Oh lordy. Yeah. Well, we're inserting it. Okay. Makes sense. Okay. Okay, you know what? Let me see if we undo the... Okay, we've got that. Let's see. It should be the messed up one. Yeah. And then we just need to take out the insert here. Take out all these. Why does it do that? Because look, if we go, this is going to be strange. If we go to remove direction and we say remove direction is now called remove dir just to test something. Now, yeah, now we're not removing our directions and our input list is coming to the wrong list. It's not going to the touch list, it's going to the, or it's, that is so weird. But if we were to come in here, yeah, okay. Dude, I guess this is like changing how I understand the program because I think these functions are global. Yeah, I think these functions are global, which makes it weird. So we'll have to do substitute any, oopsie. We'd have to go substitute any insert direction with insert touch direction. And then any remove direction, remove touch direction. That's wild. Okay, yeah. So it looks like functions are global, so we can't ever have a same function name used elsewhere because it'll just overwrite the wrong info. So that is a little strange. Okay. So we've got the basics of our input handling here. So we'll need to come up with how to do it with touch. It's tricky because, well, we have to have that touch list, because now what we can do is say, okay, for every touch button, every touch detection object that we're currently colliding with on a given frame, we're going to insert the value, the string value of that button into our input table only if it doesn't already exist in there. So at that point, we would have a touch table. And the tricky thing is, like, if we only touch one button and it's a top right on the D-pad, we would need to insert up and to the right, because we want our input list or our touch list. Because yeah, this is tough. I'm trying to think of a way we can do it smart where we can handle the touch input and the keyboard input without them getting muddled up, but I don't see a way of getting around it. If we share the same input list, it's just going to screw stuff up. Yeah, it's just going to screw stuff up. So I think we need a second touch input list that we treat as if it's the normal input list. Maybe we can toggle it, like for the web deployment, we would need the touch sensitivity, and for an iOS or Android deployment, we would need it, but for a desktop deployment, we wouldn't need it, right? Unless someone had like a touch tablet that they wanted to run the game on and put it in Game Boy mode and then use the touch controls. It's okay. I think we go about it. We keep chugging along and we try to get our touch table to equal our input table. But for touches, right? So like if we get the same behavior out of it, then when we go to modify our player, we do it based on the input table as long as there's no touch. You know, if there is touch, go use the touch device. If there's no touch, use the input table. And then we treat it the same way. So I think that's the move. Okay. So yeah, I'll be back tomorrow and I'll be tackling that. Let's see who's streaming. Kuju. Yeah, we'll just raid out to Kuju. Or you know what? We'll raid out to Hypnotic Games because he's always working on some interesting little stuff. Hypnotic. Alright, I'll be back tomorrow. We'll hopefully get our touch detection table rendering, because that is the first step to rehauling our total input so that we can use our touch buttons to actually move Tashio on screen. So that'll be great once it works, because then people can play on the phone on the website deployment. So I'm excited to get that done. I've been putting this off for a while now. We've got a decent start, so we'll keep chugging along.